A quote from Stephen Hawking: "It is possible that the universe we perceive is only a part of a much larger multiverse. In this larger universe, there could be many copies of us living in other worlds." The James Webb Telescope has now found the first real evidence for the mirror universe. Galaxies that appear older than the universe actually come from a counter-world where the physical forces are similar to ours. What is happening now? Are we now entering unknown dimensions of the multiverse for the first time, and what might we find there? The answers to this question are pushing us to the limits of normality, challenging our consciousness, and possibly catapulting us into a completely new reality. This could possibly mean the end of science as we know it. Everything is completely different. Scientists have finally discovered the true reason for the impossible galaxies, but let's start at the beginning of the story. It was the summer of 2022 when NASA proudly released the first images from the new James Webb Space Telescope. For laypeople, the depth image showed some beautiful and brilliant points of light and stars. However, experts immediately recognized an incredible cluster of very old galaxies. Younger galaxies can be seen brightly in the foreground, the older ones appear orange to reddish, and their light is diffused to blurred. With the naked eye, we can see very little here apart from a few beautiful color effects. However, the Webb telescope is able to analyze even the smallest point of light in detail. It may be hard to believe, but James Webb can tell from these blurred spots of light when the light was emitted, where it came from, which stars emitted it, how massive the galaxy was, and which elements were predominantly in it. For the first time, experts now have a complete analysis of very old galaxies in their hands. The technology of the new telescope is truly ingenious, and thanks to infrared technology, James Webb can record much finer light traces than Hubble and thus look even further. The age of a galaxy is determined by the redshift of light. If light travels through space for a very long time, the spectrum shifts from light yellow to white to red and orange. The measurements of the age of these galaxies came as a shock. One of the first confirmed galaxies in this image showed a redshift of Z equal to 13, which means it is 13.5 billion years old. Why do we see the past? Let's come to the first paradox of this story. When we look into space, we always see the past. It's crazy, but it's true. Even the light from the nearest star, Alpha Centauri, takes 4.3 light-years to reach us. If we look at the star on Earth through a telescope, we see the light that hits the lens or the observation mirror of the telescope, so we see light that has traveled 4.3 years to reach us, and that is where we see the spot of light in the sky. In reality, the star Alpha Centauri, or rather the binary star system, has already traveled further and is located at a completely different position in the universe. If James Webb captures faint pulses of light that have been traveling for 13.5 billion years, we see the galaxy there as it was an incredible 13.5 billion years ago. The depth image is therefore not only a view into the depths of the universe but also into the past. This can be a disadvantage because we will never realistically be able to see the universe on Earth as it is now. We would have to travel into space to see stars there as they are now. The advantage of this is that we are able to find out what happened in the past of the cosmos simply by observing the light. If the Big Bang really did take place 13.8 billion years ago, we should at least be able to see the epoch from which the first light was created in the form of the first stars. And here comes the problem: the first stars are not likely to have existed until at least 500 million years after the Big Bang. However, the galaxy Glass Z13 already existed 300 million years after the Big Bang, and this is a galaxy, not a single star. According to James Webb's measurement data, Glass Z13 is a highly developed, ready-made galaxy. This galaxy has taken at least 1 to 5 billion years to reach the size and luminosity that we see today, but that cannot be the case because that would mean that this galaxy already existed before the Big Bang. Starburst, or are we looking in a mirror? As you can imagine, the scientists are now really up in arms. How can such a galaxy be explained? And Glass Z13 is not alone. Shortly afterward, the existence of another galaxy with an even higher z-value was confirmed. MA's galaxy already existed 200 million years after the Big Bang and is just as well-formed a galaxy as Glass Z13. Another find even had a z-value of over 20. F200dBz045 is a highly redshifted galaxy candidate with an estimated redshift of about z equal to 20.4. This corresponds to a time about 168 million years after the Big Bang. If the measurements can be confirmed, F200dBz045 would be one of the earliest and most distant known galaxies ever observed. These three are just a selection of dozens of galaxy candidates that are still awaiting confirmation. These discoveries are called candidates because they can only be scientifically designated as galaxies once other independent research teams have confirmed the measurements. The first galaxies grew very differently than we thought. John Mather, the project leader and spiritual father of the James Webb Telescope, is certain in an interview that these findings in no way confirm that there was no Big Bang but merely indicate that stars and galaxies were formed much faster than previously assumed. Classical physics proves the man right. While modern minds no longer believe in the Big Bang, many scientists are convinced that these galaxies are the death of our old physics. So who is right? Let's take a look at what explanations classical physics has come up with in the last 2 years for these impossible galaxies. A researcher from Canada presented a study according to which the universe could be much older. He places the Big Bang at an age of 26.7 billion years ago, however, it could also be 40 billion years or more. The calculations were based on modified Newtonian physics and the theory of light by Swiss researcher Fritz Zwicky. Another explanation is that there were starbursts in the young universe, or in other words, veritable explosions of star birth, where a previously dense region of the universe produces an unusually large number of stars in a very short time. However, this explanation can only be applied partially because it's not compatible with the large-scale structures of the universe. The British researcher Roger Penrose proposed the cyclical universe back in 2015, according to which our cosmos emerged directly from a precursor universe, and some objects or basic structures of the old cosmos may have been preserved. This could now fit because Penrose's idea can certainly explain why there are galaxies that were far too old far too early. All these theories have a common weakness: they can only partially explain the new discoveries but not completely. The latest deep image of another shock. About a year after the first image was taken, the Webb telescope took another depth image. The scientists looked excitedly into a slightly different corner of the universe. Would a different picture be revealed there? No, unfortunately not, or perhaps fortunately. The second image confirmed the findings of the first depth image. The new image also showed rows of galaxies that are so old that they should not even exist according to the previous standards of physics. On top of that, this image also revealed a previously unidentified structure that lies hidden behind the Pandora galaxy cluster and, in terms of its size and dimensions, could not actually have existed in young space. The conservative physicists are slowly running out of explanations, and the stage is being cleared for completely new theories in science. We have the confirmed fact that our physics of the smallest particles is not yet compatible with the physics of the large phenomena in the cosmos. Quantum physics and astrophysics cannot be described using standardized formulas. The only theory that comes close is string theory, which leads directly to the multiverse, which classical physicists are still struggling through. But it's already clear to many: here we have the evidence for the multiverse and for a mirror universe. If the world of the smallest particles is only compatible with large parts such as stars and galaxies, if we assume more dimensions than the 4 known dimensions of space and time, then there must be other worlds that we have not yet been able to see or explore. Some researchers are of the opinion that not being able to see is actually not true at all. They say that we encounter these dimensions wherever science encounters unsolvable problems, such as now with the impossible galaxies. Let's look at the evidence that we are not looking at the young universe after the Big Bang but at the threshold to the mirror universe. Let's assume that our cosmos exists like one half of an hourglass, the mirror universe is then the other half of the hourglass. Somewhere, there is a transition or threshold where the two universes meet and interact. Now, in a multidimensional cosmos, this is not necessarily just one place, these transitions can be in several places and at several times. If we look at the depth image, we can imagine that we look back in time into the hourglass, and puff, we can even look through the magic telescope of James Webb to the other side. One galaxy that is particularly predestined to support this theory is the Schrodinger galaxy, or SE17499. Not only does this galaxy appear to be unusually old, it also provides different measurements of its location. Astronomers, therefore, jokingly refer to the physics as Schrödinger's galaxy. Schrödinger's cat is a thought experiment in quantum physics which basically states that nothing in this world has a defined real form until it's measured or observed. Outside of this measurement, all things exist in a kind of suspended state in which the building blocks of matter can exist as undefined waves or bands in several times and places simultaneously. A galaxy that exhibits precisely this effect could be located exactly on the mirror line and at that transition from one universe to another. But Schrödinger's experiment says much more in its continuation. Every possible outcome of the experiment creates its own reality, and that would mean that there are countless universes and that you and I exist in all of these universes at the same time, and we don't notice any of it. Press the subscribe button now, there are many more video highlights to come.